Hydrograph analysis part 2. From the previous part, we can derive the unit hydrographs using the constant rainfall intensity. But for this top part, if the rainfall intensity is vary, we can also derive the unit hydrograph from the various rainfall intensity using the discrete convolution equation to allow the computation of the Lect of hydrograph Pn from the excess rainfall Pn using and the unit hydrograph U. Okay, based on this equation. Okay, but for the graphical presentation, we can look at this picture to show how it works. In this case, if the rainfall intensity is vary, we can divide into small short term. For example, for P1, so this is constant for P1, and this constant for P2 and for P3. So make the duration of rainfall short. So we keep the constant P1, P2, P3, and combine with the unit hydrographs. That is the unit hydrograph for the first set for P1. So we multiply the P1 with U1 until U6, and the next we use another set of unit hydrographs times the P2, and you can see the time lag between the first set and the second set, and the third set is the unit hydrograph for P3. Okay, and the next we make combination combine three sets of the P1, P2, P3 together. And for example, in this case, if the P2 is here, so the combination, this part of the P2 contribute to the stream flow. So we got the direct line of hydrographs from the combination, from the summation of the Q. Okay, this is from equation for summation. Okay. In this case, the first, we don't know what is the unit hydrograph, so we have to find to derive the unit hydrograph. So we call reverse process. So it means we don't know U. We have to find U from Q and P. So we have to use reverse process called deconvolution, given the P and Q to find U. And to explain this equation, capital M is power of the excess rainfall, and N is power of the runoff, direct runoff. Okay. So in terms of N equation, we can estimate number of the unit hydrographs. We can use this equation to find this number of the unit hydrograph, or the unknown equation. If we can extend this equation in terms of the series, so for example, if M is 3, so it means we can 3 mean the number of the excess rainfall can be P1, P2, P3. Okay, and if the N is 6, so it means we have U1 until U6. Okay, and we can, from U and P, we can find the Q. For example, N equal to 1, M is equal to 1. Okay, and then we got the first series Q1 equal P1 U1 subtract 1 plus 1. We got P1 U1. And if N is 2, M is 1 and 2. Okay, because equation is, you can see that N is always less than or equal to M. Okay, and we got this is Q2. Okay, so we got Q2 is equal to P1 U2 subtract 1 plus 1 and P2 U2 subtract 2 plus 1. So you remember that this is away M, this is away M, okay, and this is for N, okay. And if N is 3, M can be 1, 2, 3, so Q3 is equal to P1 U3 subtract 1 plus 1 P2 U3 subtract 2 plus 1 and P3 and P1 U3 subtract 1 plus 1. Okay, so we can estimate number of Q number of Q if M is 3, N is 6 and subtract 1, so we got 8. So it means we can rewrite Q3 until the final is Q8. Okay, to find the 8 equation to estimate the direct runoff hydrographs. And the next, we have to work on the reverse process to estimate unit hydrographs of QU or given PM and QN. Yeah, we have to find QU using convolution method. And number of, you can estimate number of QU is equal to N subtract M plus 1. Okay, and from series of the equation we can use this table to explain the same as I explained Q1, Q2, Q3, and we can estimate Q1 to Qn. Okay, and in our case, if M is 3, so means Q4 is equal to but in our case P3 is 0, so this term is 0, so we still have only 3 terms based on the number of the excess power, the number of powers of excess rainfall, or